The night the defense went blind for 14 a.m., the dam stood in darkness, the massive concrete structure reinforced, rebuilt, and guarded by layers of modern air defense, looked untouchable. Months of engineering effort had gone into restoring it. Hundreds of millions of dollars had been poured into steel, concrete radar arrays, interceptor batteries, and patrol units positioned around the reservoir. From a distance, it seemed impregnable, but modern warfare does not begin with noise. It begins with calculation, long before the first explosion, long before radar screens flashed warnings. The real battle had already started, inside algorithms, inside timing windows, inside human assumptions. The first move came quietly at 3:45. A .M. high above the cold river, small airborne objects lifted into the night. They were not advanced stealth aircraft. They were not expensive drones. In fact, many of them were crude, assembled from commercial components, basic motors, simple circuitry. Their true weapon was not explosive power, it was deception, they climbed. Each carried a specialized radar reflector designed to imitate the signal profile of high-performance fighter jets. On a radar screen, they would not appear as cardboard and wiring. They would appear as fast-approaching combat aircraft. Inside the Air Defense Command Vehicle, operators saw what looked like multiple hostile targets moving toward the dam at speed. 12. Signatures. Heavy aircraft closing distance rapidly. The decision window was short. Modern air defense doctrine prioritizes immediate interception when critical infrastructure is threatened. Hesitation could mean catastrophic damage. The intercept command was given, missiles. Launched, each interceptor streaked into the night at supersonic speed, guided by precise tracking systems. One by one, the targets disappeared from the radar display. Icons blinked out success, more than 90%. Interception rate. The operators felt the surge of confidence that comes with visible control. The system was performing exactly as designed, but beneath that success was a simple mathematical imbalance. Each interceptor cost hundreds of thousands of dollars. Each decoy cost a fraction of that, and more importantly, every launch reduced. The available defensive capacity, 40-8 close-range interceptors, were mounted on the mobile battery protecting the site. With each engagement, the launcher moved closer to empty. By the time the last decoy faded from radar, the system had expended nearly all of its ready munitions. The screen cleared. Silence returned to the defenders. The threat appeared neutralized. What they did not realize was that the first phase had never been meant to destroy anything it was meant to exhaust. At 4 a.m., the second phase began. This time, the objects rising into the sky were different. Lower altitude, smaller signature, more purposeful anti-radiation drones. Their function was not to attack the dam. It was to hunt the radar itself. Every advanced air defense system depends on one thing above all else: detection. Radar must emit powerful electromagnetic pulses to see far. But those emissions also reveal its own position. The stronger the radar signal, the brighter it appears to a seeker designed to track it. The hunting drones climbed just enough to capture the specific radiation signature of the primary surveillance radar. Once locked, they followed it like moths drawn to a flame. Operators detected them. But late, large interceptors were launched to destroy the incoming threats. 2 drones were hit in mid-air, exploding in flashes of orange against the night sky. Relief, again. But swarm arithmetic does not rely on a single attempt. The remaining drones adjusted trajectory, riding the very emissions meant to detect them. They did not aim randomly. They targeted the phased array antenna, the system's eyes. Moments later, impact. Inside the command vehicle, radar screens flickered. Data streams glitched. Then the display dissolved into gray static. The primary long-range radar had gone offline. In an instant, the defensive network's detection range collapsed from hundreds of kilometers to near blindness. No clear target. Data, no reliable tracking, no confident interception. The air defense umbrella had been pierced not by brute force, but by forcing it to reveal itself. For minutes, that was all it took for the outer shield to weaken, but the operation was not finished. While attention remained fixed on the sky, another threat was moving silently across the water. Low profile. Unmanned surface vessels cut through the dark reservoir, barely visible above the surface. Each carried a heavy explosive payload. They were guided remotely, navigating toward structural weak points identified from previous damage. Their purpose was not to destroy the entire dam in one strike. It was to exploit stress fractures to widen cracks, to create internal vulnerabilities. When the first underwater detonation occurred, it was deep and muted, a shockwave traveling through reinforced concrete. Steel rebar strained, hairline fractures expanded. Defenders responded with patrol boats and helicopter fire. Some of the unmanned vessels were destroyed before reaching their target, but not all. One reached the base of a critical gate structure. The explosion did not collapse the dam outright. Instead, it altered the physics inside it. Reinforced concrete, when subjected to asymmetric stress and internal shock, begins to behave unpredictably. Fractures propagate. Water pressure amplifies weaknesses. A small leak becomes a widening crack, and when a reservoir is near maximum capacity, water itself becomes a weapon. High above, beyond immediate detection range, a final element had been waiting. A combat aircraft, operating at extremely low altitude, approached, using terrain masking to avoid radar horizons. At such low height, it remained hidden beneath the curvature limits of ground-based detection systems. When it reached launch position, long-range precision cruise missiles separated from its wings. Unlike older systems, these weapons did not rely solely on satellite navigation. Heavy electronic jamming filled the airspace. GPS signals were disrupted, but the missiles switched to imaging infrared guidance. Instead of listening for coordinates, they looked for a specific heat and shape signature, the already damaged gate structure. Electronic interference became irrelevant. As interceptors scrambled to respond, 3 missiles were destroyed mid-air. 1 remained in its final seconds. It adjusted trajectory, homing in on the exact point weakened by earlier underwater blasts. The warhead penetrated deep into the structure. Before detonating, this was not surface damage, it was internal collapse. Concrete shattered from within. Reinforcement bars twisted under immense hydraulic force. The reservoir, pressing with millions of tons of water, surged through the compromised section. When water decides to move, engineering alone cannot always stop it. The breach expanded. Not instantly catastrophic, but irreversible from start to finish. The operation followed a clear logic. Phase 1. Deplete close-range defenses with inexpensive decoys. Phase 2. Blind long-range radar through anti-radiation strikes. Phase 3. Exploit structural vulnerabilities using layered precision attacks. No single weapon won the battle. It was the sequence that mattered. Modern warfare increasingly revolves around this principle. Overwhelm through integration. Combined deception, electronic warfare, unmanned systems, precision munitions, and timing. Force advanced defenses into reactive patterns. Turn their strengths into exposure. The lesson was stark. There is no absolutely invulnerable defense. Every system has a threshold, financial, technical, or psychological. Build higher walls, and opponents study how to bypass them. Strengthen radar range, and adversaries design seekers that follow the emissions. Stockpile interceptors, and swarm tactics aim to drain them. Attack and defense evolved together, spiraling forward. That night demonstrated something beyond the destruction of concrete and steel. It revealed the fragile balance between cost and creativity, between technology and adaptation. In the end, the most powerful weapon was not the largest missile, it was coordination, a reminder that in modern conflict, victory often belongs not to the side with the heaviest armor, but to the side that understands systems as a whole. And at 4:14 a.m., when the screens went dark, that understanding made all the difference.